guys, today's lesson is on angle relationships in circles. Today we're going to look at finding the measures of angles formed by lines that intersect circles. Okay, we've already taken a look at the inscribed angle. If you recall, the inscribed angle, remember an inscribed angle actually the points, the vertex point specifically touches the circle as well as the other points on that angle. They all touch the circle. That's inscribed. We know that we learned that the angle measure here is equal to half of whatever the arc is, okay, the arc between those 2 points. So if that arc is 80, that means that this angle down here is going to be 40. Okay, this next concept relates directly to that, okay? It's called a tangent chord angle. It's an angle formed by a tangent and a chord. So the chord, again, from here to here, and of course, this is our tangent line. Okay, so in any kind of angle formed by a tangent and a chord, it's called a tangent chord angle. And the way that we find it is that it's the same way we do this one. If you take this angle right here, and yes, some of it does go outside the circle, but that angle is going to be half of whatever that arc is. So the tangent chord angle is equal to half the arc. So these two rules are the same, whether it's an inscribed angle or it's an angle formed by a tangent and a chord. The rule is the same. So in this case, once again, let's say that this arc is 100, that means that that angle in there would be 50 degrees. Okay? All right, let's take a look at applying this rule. All right, look at the first one. Our arc, and you're always looking at the arc from one end point of the chord to the other end point of the chord, from G to H. That's the arc we need to use, from G to H. It's the end points of the chord is where we need that arc. So that whole arc is 216. So we're going to take half of 216 to find the angle. And half of 216 would be 108. So that angle right there would be 108 degrees. Okay, let's look at the next one. Same thing. We have the angle this time though, okay? And we know that the angle is equal to half the arc. So it's the same thing as saying 2 times the angle would equal the arc. Okay, 2 angles equal 1 arc, or cut the arc in half and you get the angle. So either way. So we're going to take 2 times our angle there of 64 degrees, and that is going to equal our arc measurement. And it works out to be 128. Okay, so this arc LM is 128. And if you go back and check, remember, think about it. If that's 64 times 2 is 108. 128. Half of 128 is 64. So those two have that direct relationship, just like over here. You half the arc to get the angle. You double the angle to get the arc. Okay, let's look at the next one here. We got to find the measure of angle EFH. I should put that answer in here. Okay, we're going to find the measure of angle EFH. All right, so again, there's that chord, right? There's that angle we're talking about. We're trying to find that whole angle, but that chord's important because from one end point of the chord to the other end point of the chord, that is where you're going to find your arc. So your arc there is 130. So half the arc, you get the angle. So half of the 130 there would equal 65. Okay, so the angle would equal 65 there. Okay, all right, so we just found that one. Now we have to find arc GH. Okay, now this one's going to be a little trickier. All right, so if we follow this, I tried to color it a different color, but let me use a highlighter on this one. All right, so this angle right here is 122. That's important. And if you notice that the chord FG starts at F and goes all the way around here to G, because the angle is open this way, not this way, this direction. So we want all of this arc. All of that arc is associated with that angle. So if I take 2 times that 122, right, we are going to get 244. So that whole entire arc in yellow there is 244. Okay. Now, what that means for us is we have to find this little piece that goes from here to here. This is what we're looking for, from G to H. So, all of this is 244. You already know this is 130. So we have to now take the 244 minus the 130, right? And we're going to see what we get. 244 minus 130 gives us 114. So taking that whole thing, that 244, subtracting the piece we already have, the 130. So the rest of this is going to be 114. So that's that measurement of that arc from here to here. Okay, let's look at the next one. We're going to find angle STU. Angle STU is highlighted here in red. Starts at S and goes all the way around to T. That's that blue arc there. Remember, this angle is associated with this arc right here. So to find this, we have to say, okay, we're trying to find the angle. It's equal to half the arc. So we're going to take half of 166, so our angle is equal to 83. So that angle right there is 83 degrees. Now they're asking us to find arc SR. Now, look at arc SR. It starts at S, ends at R. You have an angle associated with that right here. This angle QRS is associated with that arc right there. So 71 is that angle. So to find this one, to find the arc, we have to take 2 times the angle, right? So the arc there, SR, is equal to 2 times 71, right? 2 times 71. So we get 142 for that arc right there. Okay, so that's all for tangent chord angles. And yes, that can be confusing, but focus on the angle. Also focus on the arc that starts at one end point there at the vertex of the angle and goes all to the other end. So it's your chord one you're focusing on. That arc is what you need. And if you have that arc, you can find that angle by cutting it in half. Or if you have the angle, you can multiply it by 2 to get the arc. All right, let's look at the next theorem. This one deals with angles formed by 2 chords, okay? Right in here, you have angles, 2 angles, and we know they're vertical, right? All vertical angles are going to be equal to each other, so these 2 angles are going to be equal. Now, you have learned about central angles already. A central angle is an angle that actually comes out from the center of the circle, right? So if this angle here is 50 degrees, that arc is also 50. That's an old concept. But in this case here, that angle 1 is not coming from the center of the circle. It's kind of a random floating angle inside the circle. So we've got to have a way to do it. You can't just say it's half. I mean, let's say that this arc here is 70 degrees. You can't tell me that's 35 because then that means that would be 35, right? Or I'm sorry, you can't tell me that would be 70, right? Because that wouldn't be 70. And if that angle's 70, that arc's not 70 either. Sorry, I'm getting confused there. So here, if this is 70, we're not going to say angle 1 is 70. It's not the same concept as this. All right, if this is 70, this is not 70 because then that would be 70 and that would be 70. And clearly that is much tinier than this one. So those 2 are not equal to each other. Just like in that case, well, these angles will be equal, but the arcs are not equal. So here's what we have to do. In order to find the angles, and we're finding both of them because they're going to be vertical angles, you take the sum of the 2 arcs. So we're going to take this arc plus this arc. Now let's say that this arc over here is 30 degrees, okay? We're going to add these 2 arcs together, right? That's what we're going to do, and divide them by 2, okay? So to find the angle here, the measure of angle 1 in this case, we're going to take the one arc of 70 plus the other arc of 30 and divide that by 2. So that's going to be 100 divided by 2. Our angle there is 50 degrees. So the measure of angle 1 is 50, and then this angle would also be 50 on that side because they're vertical. So it's half the sum of the 2 arcs together is how you find that, half the sum. Okay, of the arc plus the arc. All right, let's do some examples with this. Okay, take a look up top here. Same idea, we need to find these 2 angles. This is a random angle in the circle. The center would be like maybe over here, right? That would be circle O. Clearly it's not coming from the center of the circle, it's a random angle inside the circle. We find that by taking this arc plus this arc and dividing by 2. So we're going to set it up. Our angle is equal to 70 plus 52 divided by 2. So we get 122 divided by 2, and that answer works out to be 61. Okay? All right, let's look at the next one. We're going to find the measure of angle STR. Okay, that's STR. That's this angle right here. Over in this one, we were finding JML. That was that one there. So this time we're finding this. But again, these are the same, just like these 2 would be the same. They're vertical. Okay, so to find the angle there that we're looking for, we're going to take the 107, that's the one arc, plus the other arc of 99. We're going to add those together and divide by 2. So that gives us 206 divided by 2, which works out to be 103. So that angle in there is 103 degrees. Okay? All right, that's for angles inside the circle. The next 3 concepts here are all for angles outside the circle. Okay, these are for angles formed outside the circle. All right, so basically what this says is that whether you have a secant and a tangent, that's what you see here, one secant, one tangent, you have 2 tangents, or you have 2 secants. The rule is the same for all of them. What's going to happen is you take the big arc minus the small arc and divide it by 2. So it's half the sum of the difference. So when the angles are outside the circle, we're going to take the big arc minus the small arc divided by 2. So for each one of these examples, big minus small divided by 2, and you will find that angle right there outside the circle. Big minus small divided by 2. to find that angle, and big minus small divided by 2 to find that angle. Okay, so the rule is the same. Half the difference of the arcs. All right, let's take a look at these problems. All right, so again, we set it up. Big arc, this is my big, this is my small. Bigger number, smaller number, right? So 140 minus 74 divided by 2 is what I need to do there. So that's 66 divided by 2. So my angle that's outside that circle there is going to be 33 degrees. So x equals 33 degrees. And again, that's what we found right there, that angle. All right, let's look at the next one. Same idea, big minus small. Now we got a problem here. We have a big, right? But what's the small? Well, when you have two tangents, remember, this is just a point on the circle at G, and this is just a point on the circle at J. This whole arc here is 232. You have to find this missing piece, and you can do that because that's an entire circle there. So the very first thing we have to do is take 360, the entire circle, minus 232, okay? And that is going to give us 128. So the small arc is actually 128, and that only happens when you have two tangents. It will not happen with a secant and a tangent, and it will not happen with two secants. They will give you the numbers. But in this one, they may not give you this because you can easily find it by taking 360 minus whatever this number is out here. So 360 is the whole circle because that's just a point right there. So from here to here is 232. What's the rest? We subtract it, we get 128. Now we can set it up. Our angle x is equal to the big minus the small divided by 2. Okay, so when we take a look at this, we get our x is equal to 104 divided by 2, so our angle is equal to 52 degrees. So x is equal to 52. And again, you just found that angle outside the circle. All right, let's look at the next one. Again, same thing. These are two secants you see in this picture. Okay, two secants. So our angle x is equal to the big arc minus the small arc. And again, these are the arcs inside here. Big minus small, the ones inside of the angle. Okay, divided by 2. So when we set this one up, we get 46 divided by 2. Our angle is equal to 23. So again, this angle outside the circle here is equal to 23. In the last picture here, you again see that you have two secants. This one's a tiny bit different because they give you the angle measure this time. So we're just going to put the angle in the formula. 35 is equal to the big arc, 108, minus the small arc of x divided by 2. All right, we're going to have to solve this. Now, in algebra, the first thing I would do is multiply by 2 on both sides, right? I would multiply by 2 on this side, okay, and that would cancel those out, and I would multiply by 2 on this side. So that's going to give me 70 on this side equals 108 minus x, okay? Now I'm going to subtract 108 from both sides. Okay, I'm going to end up with a negative number here. Okay, so let's see what we get. All right, so again, I know it's going to be negative here, but that's okay. Right, that's going to be okay. So we're going to take 70 minus 108, and you get negative 38. So negative 38 is equal to, you have a negative x here, right? That's why it's okay, because you're now going to divide by negative 1 on both sides, and x would just equal 38. Okay, so that's our answer for that one. That arc right there is 38 degrees, and that's what we just found, that arc. Okay? So that one's a little bit different because they gave you the angle and you had to find the arc. You're just solving the algebra. Multiply both sides by 2 and then the problem will work out for you. Okay? All right, let's do a quick summary of all the types of angles that are inside of circles. Let's take a look at this. Okay, so right now we have 4 different types of angles in circles. Okay, in, on, out, whatever, however you want to look at it. Okay, but these are all angle relationships in circles. So the first one is our central angle. That's where you have the actual vertex of the angle at the center of the circle. Whatever that angle is, that arc will be identically the same, right? So if this is 40, then this is also 40. They are equal to each other. For the inscribed angle, that one is equal to half. So that's when you have your vertex right on the circle. That angle's vertex is on the circle. So for that one, the arc that falls in between that angle there, that 120, you'd cut that in half to get the angle. So the angle there is equal to half the arc. Or we also said that 2 times the angle is equal to the arc. And this is the same thing for the tangent chord angle. So the inscribed angles and also the tangent chord angle as well is the same thing. That was the new one we had today. All right, so for this one, same idea. You have a chord. You have a tangent. Your arc is in between, right, that chord that starts at one endpoint and goes to the other. So right in there, you have that arc. So you're going to take the arc, cut it in half, and you get the angle. So again, those 2 rules are the same. When you have an angle inside the circle, this is a random angle. This is not an angle coming from the center. We're talking about kind of a random floating angle inside the circle. For this type, you have to take your two arcs, add them together, and divide by 2, right? Your angle is equal to the arc plus the arc divided by 2. So when it's inside, you're going to add divide by 2. When it's outside, like the ones we had just talked about, these are the ones to find that angle, you have to subtract the arcs, divide by 2. And these are angles formed by a tangent and a secant, 2 secants, or even 2 tangents, okay? So this is a summary here of all your rules. I'm going to post a picture of that for you so that you can see it, but the idea is that's all your rules. So this is a good reference sheet, okay? All right, guys, good luck. Go back and watch any part of this you missed.